All right, welcome to MEC 1340. We're going to get started with our first part of programming PLCs. And the most important thing is being able to set up your PLC correctly so that you can start writing your ladder logic right from the get-go. So we are in Siemens TIA portal and we are working on version 15. So when you open up Portal, this is the main screen. This is what you're going to see. It gives you the options to open an existing project, create a new project, and migrate a project. We're not going to do too much migration here. We do have some programs that we've done on the 315s and 314s that we need to migrate, and that's when we're going from an older PLC to a newer PLC. You can take the old existing program and adapt everything to the new PLC. So that's what migration is. For us, we're going to open existing programs once we're constantly working on our programs in and out of class, and adapting to it. So when you're programming your final, you're going to be editing that a lot, so you're going to open an existing. So for us, though, most important part, we're going to create a new program today. All right, so we're going to go over here on the left-hand side and click Create a New Program. First thing, I'm just going to call this one Project 8. It's what's defaulting right now. But you're going to call it like Lights Program or Stoplight or Garage Door, whatever program we're working on. All right, and then path-wise, you're going to put it onto your hard drive so it's always there. Always try to put everything in the same path. Now, there is a default path where we throw things in automation, but as long as you're putting everything on the hard drive, I don't recommend putting it on a network drive for what we're doing at school for multiple reasons, just in case it falls out. Okay. We can use different versions and things like this. It's going to default to version 15 for us, and then I'm the author on this one. You're going to have your name there if you're logged in. So everything's kind of set to go. Make sure you got a path that exists. Network paths aren't necessarily good either, because if you want to work from home or things like that and you don't have access to the network, it's not going to work very well either. All right, so we're going to go here and click on the Create button. So it takes a minute or two, hopefully a little less, kind of depends on your computer. I got a fairly fast one for it to create and set everything up. All right, so you're going to get this view. You can walk through the parts here where it has configure device, write the program, do that. It's kind of like the setup wizard when you go through normal software programming and things like that. I don't necessarily like to do that, so we're going to go down to the bottom and open the project view. All right. When we open the project view, it's going to give us all that stuff anyways on the left-hand side. So your screen's going to go somewhere to this. Okay. For us, first steps, and this video is really just teaching you how to add your PLC, the right PLC, and the tags, and changing the I/O. Something that you're going to do every single time you start a new program. Everything has to be configured correctly. So this is going to be your go-to. By the end of the class or the end of the semester, this should be nothing for you. You should be able to retain how to do this. Remember, we're working with Siemens TIA portal, so it is going to be different if you use Mitsubishi or Allen Bradley or their software. So this is pretty specific. This is up to date right now for us. So we're going to click on Add New Device, double click. All right, and it's going to give us some choices. So for us, depending on what labs we're doing on or we're working on class, we have some of the 300s. So we could go down here and we can choose the different 300s. We have the 314s and we have a 315. But the majority of what we're going to be doing is on the 1500s. Some of the labs we have for motor controls have the 1200, but we're going to focus on the 1500 here. So you're going to click the arrow here, and then we have to choose the right CPU. There is a plethora of CPUs to choose from. So where we see this tag, is at the upper left-hand corner of our PLC as we're facing it. Ours happens to be the 1512C. Now you have to choose the right CPU processor on here. That will show you when you flip up the tag on the left-hand side behind the LCD. You'll get the full tag. The one we're going to use is the 001, the CK00. So if you click on that, it's going to populate over here. So under the LCD is where you're going to get the full tag for the processor. Above the LCD on the outside of the PLC is where you will see the tag for the CPU 1512 that we have in class. Double check our PLCs though, make sure they're all the same. They should be. All right. Alright, and then this should pull up and everything should be good to go for us. If you need to make adjustments here, that's usually labeled on your PLCs. As well under the tag, ours is 2.5. Okay, so we're going to go down here and we're going to hit OK. And it's going to set everything up for us. It's very nicely automated if you've used Step 7 before. There's a little bit more process when you just use Step 7 versus TIA Portal. Remember, TIA Portal stands for Total Integrated Automation. Alright, so it gives us our PLC here, okay? And gives us the different slots that we can take a look at. So I can click on slot 1, okay, and take a look. What I'm going to do though is I want to set my I/O. Okay, so if I'm taking a look up here at my I/O, see on the module here on the kind of the upper middle right hand side, I have my my analog inputs, my digital inputs, and all the digital outputs are over there too. And I can kind of scroll over and take a look at the addresses, okay, and it tells me, you know, where they start and where they end. And I'm looking at this 0 to 9 here. That's where my analog, and then my digital here is starting at 10, 11, and then the outputs are 4 and 5. I need to change that, okay? This is very important for us in class because if you don't change that and you try to run your program, it's not going to work right, and you're going to be like, I did everything like you said. Your program's going to look really good and really right, except for you didn't tell it the right PLC I/O addresses. So what we're going to do is the analog is using the addresses that we want to. Alright, we want to use 0 and 1 for our digitals, but it's stolen by the analog right now. So we're going to give the analog just a random tag. I'm going to use like 126. So I'm going to click on this properties button down here. Okay, and I can look at my inputs, my outputs, and my I/O addresses down here, and all my different channels. Okay, and then it'll change kind of like based on the module that I click on. Notice that it changes. Okay, so I can look at my inputs here on what channel they are, and then I can look at my I/O addresses. Okay, and this is where I'm able to change them. So I'm on the analog right here. So if I click down, you can see that I'm on the analog piece for this. So I'm going to change this here to 126. Okay, and it's going to give me an ending address of 135. Notice up here, okay, up here it changed to 126 and 35 for the analogs. Okay, then I want to change my digital. So I can click on the module up here, okay, and then I'm going to go down to properties. And now when I click over here, it's going to give me my inputs, all the different inputs I have that are digital inputs, okay? And then I want to change the I/O addresses. So I've clicked up here in the upper right hand. Sometimes it defaults down here and shows you all of them, but up here in the module piece, see how I kind of have the digital input 16DQ 16_1. I have that in white. Okay, so that's what I'm working on when I'm looking at properties. And I'm on module 1 here. There's module 1, 2, and 3 on this PLC. I'm on the first module. So I'm going to change this start address for my digital input. I'm going to change that to 0. I'm going to hit enter, and my end address is 1. That's fine, because everything we're programming on the 870 station goes from 00 through 07, 10 through 17. There is some 2s being used, but we're not going to worry about that right now. If we do want to use 2, alright, you would change the end address here to 2. Alright, so it's important here. And then we want to make sure our output address is going to be right as well. Okay, so I can go up here and double check on my I/O. My starting is 0, 1, and my output is 4 and 5. If I want to see my output, I just scroll down a little bit. Those are my output addresses. And what I've showed you on the 870 trainer, alright, outputs are 4.0 through 4.7 and 5.0 through 5.7. So that's where those lie. Alright, but like I said, if we wanted to make this 0 to 2, that's fine. I can highlight that. Alright, and it won't let me because 2 is locked out on this one. So we'll have to take a look a little later on. That means something else is using the 2 right now and I can't use it on it's designated. So, but we'll get to that a little later on because we're not going to program anything above and beyond that. With what we're doing anyways. Okay, so now that we have our I/O tags or addresses correct, we're going to come over here on the left hand side, and we want to click the arrow down here where we have PLC tags. Okay, I don't necessarily ever use the default tag table. You can, but I like to make a new one based on the tags that I want for my program. So I'm going to double click add new tag table, and it's going to drop this tag table down here. You can name it something else if you want. I just kind of keep it as whatever defaults to, just for what we're doing for class. So when you do this tag table, it's important that you know all the different I/O addresses that you're going to use when you're programming. So for us, all right, I want to use the start button. So I'm going to call it start. That's the name for the button. It's going to give me my first default input address. Notice that this is Siemens tagging. Okay, so we're going to have the percent sign. That's an I 0.0. So now that's the address on the 870 trainer for the start button. All right, for us to actually hit start and get something, moving or things like that. I'm going to add, I'm going to just make up some stuff here just so that we can, see how we're setting up our PLC. Everything else that you're going to do is lab specific and trainer specific and those sort of things. So here we're going to add, okay, or a STO, so I can't spell. We'll call it a stop. Well, I figured out why my P button's not working right. The program I'm using to record, all right, I use the P button to pause it when I do things, so the video just sounded kind of crappy probably because it went in and out. Well, that was me hitting the P button to type stop. So I'm just going to call this stow over here, and look how it defaults to the next possible input address of 0.1. All right, let's do some outputs here. All right, so let's just do like a green light. Green light. Okay, I'm going to hit enter, and notice it defaults to the next input. I don't want an input, right? I want an output. So I'm going to click over here, and I'm going to change this to a Q. It gives you three choices right here under identifier. When I pull this down, it gives me I, Q, and M. I is for input, Q is for output, and M is for a memory coil. All right, we're going to talk about those later on, but that's just internal storage. It's not an actual physical element that we're programming. Okay, but I'm going to choose Q. All right, I'm going to tell it I want address 4, and I want it to be bit number 0. That's my first output address, and then I click the check mark. Now, okay, it's going to put Q 4.0 there for me. So now the next thing I type in, let's just type in like red light. All right, so we got red light. Notice how it defaults to the next Q that we have. Okay, and we're going to keep data type Boolean. This is going to change when we do timers and counters and that sort of thing, but for when we're doing Boolean stuff, it's literally just our normally open, normally closed contactors and our activation coils and things like that. So we got some basic tags here. I'm not going to write a relevant program for you. I'm just doing this so that we understand we have to set up I/O tags when we do this. Okay, now that I got my tag table set up, okay, I'm going to create a program block. So under program blocks, I'm going to hit the little arrow, and there's a main, okay, OB1. Okay, we can do a lot of Star Wars references, okay, but that's our block 1. So when this comes up, this is our first network. Okay, now we're going to drop in a normally open contactor. If yours don't default here, where you see them where they're above my block title here on my main program suite. I have a normally open contactor, okay, normally closed contactor, and you can hold the cursor over it and it should tell you what it is as far as that goes, so normally closed contactor, so on and so forth. Okay, the main library is over here on the right hand side though, so you'll see this falls under bit logic operations, and I can choose the down arrow and it gives me it. It even gives me like a NOT, all right, and a sign. That's like our output coil. So you can either drag it from over here and drop it down, or you can drag it from up here and drop it down. So I'm going to drag this normally open contactor and put it on the rung here. Notice it doesn't automatically default anything in. So what I need to do is I'm going to click here, and then this is where you've already created your I/O tags. So I click here, all right, and I can go down and be like, oh, I need the start button. It's right here. All right, and I'm going to hit enter, and it puts it there for me. So it gives me the actual address, and then in parentheses it's going to give me what I called that IO. So that's my start button. And then I'm going to give it an output. So I'm going to grab up here the assign and just drop it on the rung, and then I have to give it a tag as well. So I'm going to double click here, and I'm going to go down, and let's just say I want green light. Okay, so all I've got here is a push button that turns on a light. Really fancy program here. And then say I want to, on another network, I want to do something else. Okay, so I'm going to put our stop buttons are normally wired closed, so I'm going to put a normally closed on here. I don't have to. I can make it normally open, and that's completely fine too, because then it'll open the wiring when I press it, but it'll show active when I'm doing it. So be very careful when you do a stop button. I'm just doing this for the sake of just showing you guys how to make the program right now. Not a relevant program, but just setting up the PLC. So you need to be very careful when we do like e-stops or stop buttons, because they're normally wired closed. So we can still use a normally open contactor to program the stop button. Okay? And let's say, okay, I didn't want to do that. So let's say I wanted to keep the stop button as normally open. So I would activate it, and it would be live because it would be wired behind the scenes, and actually when I activate it here, it would stop. So say I didn't like that I did that with a normally closed contactor, I'm going to hit delete, and it goes away. So alright, let's say I wanted to make sure the stop button here was, and you can see where it keeps adding networks for you. But let's put this as the stop button and use a normally open contactor for stop. Alright, remember I had to call that one stow because of my pause button. Okay, and let's say, alright, I needed to add, say I wanted it only to happen when it was not the start button. Okay, so if the start button's not pushed, I'm going to drag this normally closed contactor here, and I'm going to pull here and tag it, and I'm going to be like, oh, okay, so this is when it's not started. So the stop button, not started, and then I need an output, and let's say I want to throw the red light on here. So I double click here, pull it down, and I'm choosing the red light. Okay, so now I've done a few steps here. We've set up the PLC, set up the tags, and set up the main block. The last thing you do before you upload is compile. So you're going to go up here to this button here, and I can hold the cursor over it, and you can see that it pulls up compile. I'm going to hit it. Now, before I do that, I'm going to make sure that I highlight the PLC over here on the left-hand side where it has PLC1 CPU 1512 CPN. That's my PLC. I want to make sure that I highlight that before I compile. Now, later down the line here, this is where we're going to download to device. I'm going to do that in a different video for you. All right, we can upload from the device. So that means if there's a program already on the PLC that you want to use or save, you can upload it, all right, and store it and save it somewhere else when you want to do that. So what you'll do later on is make a few changes, and then you can just re-download the block. But on the initial download, we want to compile everything and then download the whole PLC versus the block. Sometimes you can screw some things up if you just do the block and you don't have all the correct matching CPUs and everything on the PLC. Alright, so I'm going to hit the compile button here. Alright, so it's just making sure that we didn't screw up any tags or anything along those lines, and that everything's kind of set up correctly. Alright, and then it's going to give me all these issues that I could potentially have at the bottom or things like that. So one tells me the CPU display does not contain any password protection. I'm okay with that. I don't need that right now. Alright, here's what I'm looking for. Alright, that the block was successfully compiled, all right, and it compiled finish 0 errors. Warnings, sometimes, they're kind of insignificant, telling me that it doesn't have password protection. That's fine, okay? But errors are what you don't want, okay? So from the next video, we're going to go through actually how to, download it onto the PLC and, kind of monitor the program live. So let's just recap one thing though. What did we do? We created a new program, okay? We added a new device. We had to choose the correct PLC, which was the 1500, okay? Then we had to choose the right processor. So that was a 1512C. and then we had to choose the right controller piece on that. All right, remember that tag was behind the LCD on the PLC when you flip it up. Okay, then once that was created, we had to fix the IOs. You will have to do this every single time you make a program. You will change the digital inputs, at least for what we're working on, to 0 to 1, and the outputs from 4 to 5. But remember, the analog is stealing the one we need, so you need to change the analog input to like 126, so it's not even close to anything we're using. Okay, then once you created the IO addresses correctly and they were assigned correctly, you're going to go over to the PLC tags. You created a new tag table where we created all the inputs, outputs, memory coils, and that sort of thing. And then next we went up to program block and we wrote on the main program, that's where we're doing our true ladder logic and dropping in all of our contactors and actuators and all those different things, timers, counters. Okay, that's the meat and potatoes of setting this up for us. Okay, everything else from here on out, piece of cake. Literally, you're writing your ladder logic, compiling, uploading, checking to make sure that your program works correctly, tweaking it, and just doing that. So from then on out, it'll be troubleshooting. But this video, what I'm covering, right now, this is something that you need to go over multiple times, because every single program that you write, you need to do the exact same steps that we just went through. So very important retaining this information. And like I said, once you get into your third or fourth program, you pretty much have it down. Most people tend to forget to change the IO tags. So you might want to make yourself a procedure list when you set this up and just kind of have it, stuck by you on a notebook as you're setting up everything. But that's the end of this lecture, guys. I'll see you in class for lab. Next lecture, we'll talk about actually downloading it to the PLC. Those guys have a great day. I'll see you in class.